So, hi. I'm Lars Holmberg from a small university south of here, Malmö University, perhaps heard of. And I made my PhD this spring, and it was about neural networks in context, challenges and opportunities. And that's very much aligned to what you've been doing here. And it was interesting to hear Sarah speak about things that also I will be speaking about, I think. And thank you for inviting me. So, me, myself, and Per Linde, I'm a computer scientist or interaction designer, really more, or whatever. And I work with Per Linde, also from Malmö University, and here from this house, Elke Lindström, who is a professor on biodiversity. And then I also have work with Magnus Hellström, who is at Ottenby Observatory. So after my PhD, I got a grant from Crafoord for this spring. So I sort of started up this project with ideas from my PhD that I did. And at Ottenby, they are working with migrating birds. So birds coming in, they are sexing and aging them and saying, this is a 2-year-old warbler of this and that kind. They are not interested really in species, they're interested in age and sex of the birds to both see migration patterns and also how they breeding patterns coming back and forth. So they have a season now in the spring and also in the autumn for collecting and measuring this with birds. So with that said, what I'm then looking at, what I come in here with, is this idea of that I'm interested in enhancing human cognitive abilities. I'm interested in building tools that are useful for researchers or people that are doing the kind of things you're doing. And that I denote as human in command machine learning. Of course, what we have here, we have empirical data coming in, and then we as humans then build subordinate concepts and concepts. What is a cat? What is a dog? That is, of course, a lot more versatile than the images has. So if we think an ear, we think about a lot of things when we see an ear, and not only the image. And what is often a confusion is here sort of the contextual trustworthiness for the label. It's very easy to think that, okay, if it gives you the label cat, it has some kind of knowledge or representation that is aligned with our concept of the cat. And also that the internal knowledge representations in the neural networks has something to do with ears and feet and claws and whatever. But it doesn't, there is no guarantee that it has it. There's no guarantee that the internal knowledge representation has anything to do with our subordinate concepts that we think of when we think about cats and dogs and whatever. And also that it's important to think that, okay, those systems can only see correlations, similarities, and they can't do anything about causality, because causality implies that you can do interventions, that you can sort of do changes and see what effects that has. And that is sort of the traditional problem of induction and concepts and causal explanations and references like that. So what I sort of was working on with my PhD is some human in the loop, machine in the loop, or what I denote as human in command machine learning. That is what I'm interested in sort of exploring and building as a concept. And the idea is then that the user has this feature space where, in my case, what I'm working with images then. And you have classes there. And you add images, you remove images from that, you train a model, you deploy a model, and you move the model in the model space until you're satisfied with what it can do. And you do this iteratively, and you build trust, and you have a mental model of what this system can do and can't do. And then you sort of understand out of distribution that this model can't do this and that, or you can work with how underrepresented classes that add things there, or work with data augmentation or whatever. But you as a human, you as an expert, a field expert, or whomever, get an understanding of and model how that model works, whether it's a model trained on ImageNet or some other model. But over time, you will understand. That is sort of the idea of this. So specifically, what I'm working with now, I'm sort of just worked 2 months or 3 months with this. I work with this big, huge data set. They have 70 gig of data set, and most images are 6,000, 4,000. And that is sort of very different from the sizes you put into a neural network, which is around 400 or 500 pixels times 4, or 200 to 400 pixels, if you should have enough training time. And so the first part of this would then be to say, okay, there is a lot of images in this data set that I'm not interested of. For example, this with papers on. But there are perhaps in this a simple annotation that you can do that, okay, I'm interested in tails and wings and heads. That's what I, in this research, is doing. And then I will be training that on those, and I see how does this perform inside this data set that is collected at Ottenby, which is, because I want to do research, perhaps not as the intentions from the beginning of the people that took those images. I want to explore those images in a different way, perhaps. So then I firstly would train this model, and I will see, okay, it performs pretty well, I can see the results, and then I add more training data to the classes, so I get balanced data set, and I get the accuracy or whatever that I'm interested in. And from that, the trick is really segmentation, as for example, this is using this SAM model, but connecting a taxonomy or ontology to the model. So say that, okay, we have a bird and we have wing and we have primaries and we have secondaries, and those are named like this. That sort of the professional way of noting those. Because then we want to go to explanations. So what I really in the bottom here for the case of sexing and aging birds is, okay, are those feathers molted or not molted? Have they changed them since they were born or not? Because that is really one of the significant things to see how old they are and why. And that's, of course, also individual for different species, like a willow waddler, or compared to some other species. And that's specific, and that's very specific knowledge. But then if you connect this knowledge to the segmentation, you could perhaps end up then and doing things like this, that, okay, we can have a wing here, we have a spatial distribution of the feathers, and we can say that those are molted and those are not. And then we are getting closer to the explanation, some kind of explainable artificial intelligence, where we can connect the knowledge we as humans or experts have with the reality and answer the question, why is this classified as a 2-year or a 1-year male? And get further away from GradCam and those kind of systems like Lime or whatever. They're kind of useful in saying that identify spurious correlations. They can say that, okay, if you have cat here, it would, if we looked at the door, for example, or something else, you could say, okay, that's a spurious correlation and perhaps not very good. But once you have this, you come this far, you only know that, okay, there is some kind of correlation between the internal knowledge representations in the system and our understanding of the concept of dog and cat. But it's really, really hard to get any further like that if we don't add the taxonomy and the knowledge that we as humans have around the area. So, and that is sort of the goal of this project, where I'm in the starting phase of building the machine learning pipeline for this. So it is easy to experiment, build different models, evaluate those models, make them better, and also ultimately connect them to the taxonomy you're using in this special case. That was my project. Thank you for listening.